We are looking at composition, decomposition, and decomposition of functions. So one of the things I like to do is when you look at all these things, it's telling you F or G. So it's a good idea to make one color, make the other one a different color so that you see them. If I'm a person who hurries, anybody ever get that feeling where you hurry through and then you realize you looked at the wrong thing and you did, yeah. See, so I like to say, okay, there's F, there's G. Now when I go to do my work, I'm immediately looking at yellow or I'm immediately looking at pink. Now you don't have to do that, but it's just a way to slow you down and get rid of those errors. You know how Math Lab and Delta Math are? You make a mistake, then you got to go redo the whole thing. This helps prevent that, right? So I want you to notice that these are written two different ways. That's two different ways to write the same thing. This is not two problems. You may see one of these written as f of x plus g of x, or you may see it written as f plus g of x. That's the same set of directions. It's just two different ways to write it. Now, what do you think it means when it says to add? Exactly what you think it means. It means we're going to add them up, right? So you're going to take x squared plus 1 plus 3x minus 2. If it tells you to add the functions, you just add them up. And when you add those up, what do you get? X squared plus 3x minus 1, right? That's a plus, not a weird T. Now, one thing that we have to do is you have to list the domain of this new creature you created, okay? So this is a parabola, so the domain is all real numbers, negative infinity to infinity. You can't just write that down, though. You've got to go back and look at either of your originals. If either of the originals have restrictions, then those restrictions also apply to this one. Now, that's a parabola, that's a line, so there are no restrictions, so there are no restrictions, so the domain. And when would we see domain restrictions? If we had a variable in the bottom or a negative square root, right? Okay, so f minus g of x. Now this minus, you need to make sure that you do what? Put parentheses around what you're subtracting. So I'm going to say f minus g of x equals f minus, anytime you write a minus and you have stuff following, right? Because where does this lead us? That's x squared minus 3x. But what's a minus a negative 2? It's a positive 2 plus 1 is 3. If you don't write the parentheses and you just write 3x minus 2, you're going to end up subtracting that 2, right? Again, we talked about the fact that the two given equations are a parabola and a line, so they do not have any domain restrictions. So we look at this one, that is still a parabola. And what is the domain of all parabolas? All real numbers. You know, or you could do this, but you have to go, and I think Math Lab asks you to do that. Okay. Did that really print a square? Y'all should see a dot right there. This is a printer issue. Sometimes when it prints a square, if you're at home or the copy machine, there's a dot. Now I want you to notice something very important. See how that's a dot? That means multiply. Is this a dot? No. This one is an open circle. So if you see this, that's multiply. If you see this, that's composition. If we're not intentional with the different meanings, sometimes we see that open circle and we're like, oh, I'll just multiply. Okay, so this one is, and you could see here FG, F times G, where if you look at this one, you see the circle or the G inside of the F. So pay attention to the difference between those two. This says to multiply, so I simply multiply. Right? We have two binomials, and y'all like the acronym FOIL, so we've got to make sure. So it's really the distributive method, which I like better because FOIL only works with binomials. Sometimes you get a trinomial. I'd prefer to call it the distributive method. So I'm going to distribute x squared to everyone. So that's 3x cubed minus 2x squared. Now I'll go this way, plus 3x, and there, minus 2. Is that finished? That's all finished, isn't it? So there we go. What is this creature? That's a cube. What's the domain of a cube? What's the domain of a cube? All real numbers. When is it not all real numbers? If you have a bottom or a negative square root, correct? Unless it's a function that doesn't, like a square root function, but then we know that. Okay, what does this one mean? Divide. So I divide. And I put F on top because it says F on top. I put G in the bottom or the denominator. Now, can we simplify? Can we factor anything out and divide out? No. So are there any numbers X can't be this time? Yes, we have a bottom. Whatever makes the bottom 0, so what goes in for X? So X can't be 2/3. Sometimes you'll get more than one number that X can't be. So let's look at a for sure way to find this. If you'll do a quick little sketch and say, okay, 2/3. X can't be 2/3, but it could be everything else. Then it's easy to write it because this arrow goes forever. So negative infinity to 2/3 and 2/3 to infinity. And we need to check on Math Lab. They may just want a comma in between, right? On the homework we did last time, they wanted a comma. So we have to be intentional about the way they ask. This method is really handy because if you have two excluded values, when you see the line, it'll help you remember to put the middle piece in. Sometimes we have more than two sections. Yes, sir? It wants a comma. Yeah, it does. Oh, yes, this is not a U. That's a union. But on Math Lab last time, they wanted a comma and not the union symbol. So just watch for that. We have so many different platforms now, and we don't know what you're going to use in college. So we have to get used to kind of getting friendly with the software. All right, what is this? This is f of g of x or f of g of x. That's the same thing, two different notations. What this tells us to do, this is the inside. This is the outside. You're going to plug the inside into the outside. Kind of think about plugging a plug into an outlet. You don't plug an outlet into a lamp, do you? No, you take the plug and you put it into the outlet. So we always go into the outside. And the easiest way to do that is write down what the outside function is, but instead of putting the X there, put open parentheses. So where I see F, see how F is on the outside? So I'm going to write F down, but instead of writing F, see how I wrote F, and I'm going to highlight it yellow because I highlighted F yellow. I wrote down exactly what I see up there, correct? Except I put an open parentheses instead of the X. So what's going to replace the X? It says to put G in there. So I'm going to stick this thing where that one had an X. And that's all there is to it. But you've got to know which way to plug it. If you go backwards, all is lost. And y'all, for your future, as y'all move forward into calculus, you'll get some limit definitions of derivatives and things. If you will get used to when you're going to plug something big in for an x, if you'll build the habit of putting open parentheses where x used to be, and then putting the new thing in there, it really helps when you get to limits. It will keep them from looking very confusing. Okay, so let's try that. Now, what does 3x minus 2 squared mean? I have to do this, don't I? Here's another thing that you're going to see in our next chapter here. When you see a 2 up there, I know you know that means squared, but I want you to think about, this is a factor, so I want you to think of that factor's there twice and get used to seeing it this way. That will help you when we start talking about what that number can mean. It means different things. It gives us clues to graphing that you just might not know yet. So now you have to use your distributive method or your FOIL for that. And what do we get? 9x squared minus 6x minus 12x plus 4 plus 1. Right? This part is right there. Then I have the plus 1. This is a parabola. My two original functions were parabolas, so there's no domain restrictions. And I'm going to put a note here in red. I wanted to do it the right way before we point out the obvious wrong way. This is not 9x squared plus 4. It never fails. People try to square this one, and they try to square that one, and they're done. If you do that, you've lost your middle term. So make an intentional note. Why do I bring that up? Because I see it every class, every year, someone tries that. I mean, it makes sense, right? If you're not being intentional with what you're thinking about, that just looks like the easy way. You know, you get in a hurry, you're nervous, you're trying to get a good grade, and plump, there it goes. All right. Now this one. How is F different than G? E, sorry. This time, who's where? This is the outside. This is the inside, correct? Okay, we got to take the in and plug it into the outlet. So this time we're going to write G down, and G is 3x minus 2, except we don't write the x because we're going to replace it. So we have open parentheses, and then we simply replace it with the inside. And what's the inside? Do you see the difference in those two? And we want to be really good at this. There's a lot of composition in math where we're putting two things together and figuring out what happens, right? And now that is 3x squared plus 3 minus 2, 3x squared plus 1. Again, this is a quadratic. Well, that doesn't look like a 2. There we go. This is a quadratic, so our domain, all real numbers. Do these make sense? Are these easy? It's a review. We did them before. Well, you did them last year. Now, what if I were to repeat that, but we put numbers in instead of x? We say, oh, we know what x is 2. There's two ways I could do it. I've already figured out what the addition is, right? It's right here. So I could take this 2, I could add these together like I did, and I could go plug the 2 in. Or I can plug the 2 into each one and add those up. Which way is easier? It's usually easier just to plug that number in than it is to find an equation. So I say you'll be better off to do this, right? Remember that doesn't mean times 2. It's f plus g of 2. So we do both. You could just go up here, and if you plug 2 in here, 2 squared is 4 plus 1 is 5, correct? G of 2, 2 right there. 3 times 2 is 6, minus 4 is, minus 2 is 4, and 5 plus 4 is 9. On this one, you have the equation done, so you could use it. Either way is fine. If you're just given an equation like this with the number, it's easier just to plug the number in. All right, what does this mean? Oh, that's one of those weird circles. What does that mean? You do the inside first. So I'm going to find f of 10. What is f of 10? Plug it in up here. What is that? 10 squared plus 1. And now we do the outside, and we take the answer. Whenever you have it like this, you find the answer for the inside. Then you take that answer and you plug it into the other equation. What's g of 101? 301? Does that make sense? Now you could have gone up here and used this also, because you've already done it, and that would give us 100 times 3 plus 1. But if you didn't already have this part done, it's much easier just to work with the numbers. Okay, what about the next guy? That's division. So what we're going to have is f of 3 over g of 3. And what does that equal? If I plug 3 into f, that's 10, correct? And if I plug 3 into g, 3 times 3 is 9 minus 2 is 7. Is 10 over 7 a good number? It's a perfectly fine number, right? Okay, and now we've got this one. Here's the inside, the outside. We do the inside first. So g of 1. What's g of 1? Plug 1 in up here. What do you get? 3 times 1 would be 3 minus 2, 1. Now we take that same, this 1 right here. I don't want you to get mixed up and think we use that one. The answer gets plugged into the outside. F of 1 is 2. Remember. Let's put a note there. Plug this answer into F, right? Make sure you notice, I don't like the way that came out to be the same number, right? Okay, are we good with algebra? This was the algebra part, which of course, now we have to go to the graphic part. Was that good? This easy review, not bad? Okay. So now could you do the same thing given a picture? Of course you can. Now, one thing for my eyes, that's a black, and they get them mixed up. And my eye always, if I'm looking at this, I'll always read up. I have a solution for that. What do you think the solution is? Highlight them. I'm going to make them 2 different colors. Remember, think back. How many of you have ever lost points on a test for something your eyes did to you? I did that all the time. I consider myself a fast thinker, and I think that's why. I think faster than my eyes and hands can go. How many of you have ever missed an A, like you get an 88 or an 89 because of something careless and you read it wrong? So I have come up with techniques that prevent that because I want my points. I'm very competitive, and I want the highest grade in the class. So if this were high stakes and I were taking a test, I can now go through, and I made my F graph pink. So look what I could do. What does this do for me? Does this help me? It helps me because now when I look at this, where is my eye going to go? To the pink line. When I look at the yellow pieces, it clues me in. Don't forget to look at the yellow guy. So I find this very, very helpful. Okay, this says f of 0 minus g of 0. This is x, right? You find y. So if you look at where x is 0, the pink graph, where is it? 1. Minus g of 0. So now I go to 0 and I look at the yellow graph. Where's the yellow graph when x is 0? -2. And what is 1 minus -2? 3. And if you want, you can label these 1, 2, 3, 1, 2. I'm lazy. I don't want to keep counting, right? So I could do that. All right. G divided by F. G is yellow. So I need to look at -2 and see what yellow is. Go over to -2 and yellow is 2. Go to F of -2. So now I'm going to go to pink. I'm going to go over to -2 and see how big it is. 1, 2. How big is it? -1. And 2 divided by -1 is? Does that help? You think it helps? Now, if you don't have a highlighter, you could color one of them thicker. But I would get a highlighter or a matte pencil. Okay, this is multiply. There's no symbol in between those. It's not an open circle. So I go to 2 and look at pink. 1, 2. Pink is -1. I go to yellow at 2 and it's 2. And 2 times -1 is -2. I had 2 different problems. I got the same answer. Should I panic? No, it happens. All right, here's a plug it in. So remember, inside first. So I go to yellow and I go to -2. And if I go to -2 on yellow, what's the answer? So G of -2 equals what? 2. So now I take that answer and I plug it into F. F is pink, so I go to 2 and I see how big pink is. How big is pink? -1, and this is the final answer on that. That's a composition. Not bad. All right, I'm giving you 20 seconds. Try E and F. On your mark, get set, go. I'm going to write the answer down, and I will be glad to go over those if you didn't get that, but try it out. Remember, inside first, inside first. Okay, so here we have F of -1. What's F of -1? So let's go over to -1 and see what pink is. Pink is 0. So now I find G of 0. If I'm at 0, G is at, where's G? 1. Oh, F of -1 is 0. Oh, wait, G is -2. G is yellow. Okay. Now on this one, if I go to F of 3, I go over to 3 and I look and see what pink is. Pink is -2. So now I have to find -2. And if I go over to -2, the pink line is at -1. Does that make sense? Not bad, right? I really think coloring them will keep you from having to keep saying which green line, which line. Okay. Well, we put some stuff together, and in math, if we put it together, what do we have to do next? Take it apart. So now this is the creature you made. You've got to go back and identify F and G. What were the originals you started with? Now, notice G is the inside in this particular question. They could say G of F, but they said F of G, and that's the outside. It really helps to think about them as inside and outside. So G is my inside. So when you look at this function, what is on the inside? Right? Right there. Now, if this is the inside, what did they do to that inside thing? What did they do to it? They cubed it, right? So the outside was x cubed. Now let's check that once and see if it works. So if I were doing what we did on the first page, I would take the outside, which is this one, right? I would take the outside and I would write it down, but I would leave it open. And then I would put the G in there. Did it work? Did we get the right thing? They're very easy to take apart. Okay, what's the inside on this one? X plus 4. And what was done to the x plus 4? We took the square root of it. What do you think is here? The inside would be this part. And what did we do to it? We put 1 over it. Right here, what's the inside? X minus 5. And what did we do to it? Those are always going to be pretty easy to take apart like that. We won't have any that are too bad. Okay, last example. This is very easy. We did it on the other page, but for some reason, when we switch it to a graph, people get scared. So what do you think we're supposed to do with this? Well, it's giving us the x's. How do we find the y? What do our instructions say? This says plus, so we add the values of f and g. If it said multiply, we'd multiply them. If it said subtract, we'd subtract them, right? So all I do is go to -2, and what's y? Y is -2, and y of g is 1. And what is -2 plus 1? -1. So what's the new point? It'd be -2, -1. We've already got the x. The x doesn't change, and we combine our y's. Let's go to -1. -1, what two numbers are we going to add together? So our new point is -1, 1. The x won't change, correct? We want to know what the new y is. If I go to 0, I get -1 plus 0, which is -1. So I have 0, -1. If I go to number 1, I have -1 plus 2. So my new point is 1, 1. 2, 1 plus 2 equals 3, and 2, 3. So now it's like this is mom and dad, and I want to see what their child looks like. What does their baby look like? Let's see. Is he cute? Let's check. -2, 1. -1, 1. 0, -1. 1, 1, 2, 3. Right? So there we connect the dots. There he is. Isn't he cute? I think he looks more like mom. Anyway, I wanted to show you that one example because sometimes when they tell you this, they're like, draw the new thing. You're like, what? Now that you've seen one, you're like, oh, well, that's just easy. Okay? Not bad. If you're listening in, I hope you have a great day.